March 1866, 320 feet below the surface at Dolcoath Mine, near Cambornes, Cornwall, shift captain William Trevorrow stood in the main haulage level, watching a problem that had consumed 3 hours of the morning shift. 2 ore wagons sat locked together where the 24-inch gauge tramway from the eastern workings met the 30-inch gauge main line. The smaller wagon's wheels hung uselessly between the wider rails. 1,600 weight of copper ore sat motionless, while 8 miners stood idle. Trevorrow was 52 years old, had worked underground since age 9, and had seen this exact situation 40 times in the past 2 months. The mine operated 7 different railway gauges. Every junction was a bottleneck. Every transfer cost money, and nobody could agree on how to fix it. Cornwall in the 1860s was the copper capital of the world. More than 300 active mines extracted ore from some of the deepest hard rock workings on Earth. Dolcoath would eventually reach 3,300 feet. The county produced 2/3 of global copper supply. But underground, chaos reigned. Every mine ran its own railway gauge. Some used 18 inches. Others used 24, 30, 36, or 42 inches. A few used 4 feet 8.5 inches, standard gauge. Many operated multiple gauges within the same mine. The result was an industrial nightmare. Wagons couldn't transfer between levels. Time equals 350 milliseconds. Equipment from one mine was useless in another. Simple logistics became expensive choreography. The chaos had a cause. Cornwall's mines didn't pay wages. They operated on tribute, a system where miners bid at monthly auctions for the right to work specific ground. The mine provided access and pumping. The tribute gang, usually 4 to 8 men, provided their own tools and powder. They extracted ore and received payment based on its value after processing. Rich ground paid 20 pounds per ton of copper. Poor ground paid 2 pounds. The miners gambled their labor against geology. This created fierce independence. Each gang operated like a small business. They made their own decisions. And when it came to moving ore from working face to shaft, they installed their own tramways using whatever gauge suited their needs. Narrow drifts got 18-inch track. Heavy loads got wider gauge. Cheap rails from closed mines got used regardless of width. The mine captain couldn't enforce standardization because tribute gave miners autonomy over methods. William Trevorrow's immediate problem was tactical. 1,600 weight of ore needed to reach the shaft. He had 2 incompatible wagons and 8 men burning time. The orthodox solution was hand shoveling from one wagon to another. 15 minutes per load with 2 men. Trevorrow had the narrow wagon lifted by hand, placed on a flat wagon that fit the wide rails, and pushed as a unit to the shaft. This required 6 men to lift 300 weight plus ore. The risk of injury was significant. One man had lost 3 fingers in a similar operation the previous month. The incident wasn't unusual. Dolcoath's logs from 1866 show 127 separate delays attributed to gauge incompatibility, averaging 2.4 hours each. At 4 pounds per hour operational cost, this represented 1,220 pounds in lost productivity. 2.7% of annual ore revenue consumed by preventable inefficiency. Captain Josiah Hitchens, chief engineer from 1858 to 1874, wrote to shareholders, "The multiplicity of wagon gauges continues to impose costs. Rational man might conclude that standardization would yield economy, but rational economics founder upon the realities of tribute working and existing capital investment." The problem intensified with mechanization. Early tramways used human or horsepower. Gauge barely mattered because loads were small and transfer was manual. But steam locomotives changed everything. Starting in the 1850s, larger mines installed underground locomotives, extraordinary machines operating in 5-foot headroom, navigating 20-foot radius curves, hauling trains through steam and water spray. Dolcoath installed its first in 1862, a 4-ton vertical boiler design built by Harvey and Company of Hale. Cost, 340 pounds. The machine could pull 8 loaded wagons where 6 men previously managed 2. The efficiency gain was extraordinary. But the locomotive ran on 30-inch gauge. It couldn't access the 24-inch or 18-inch branch lines. The solution was transshipment. Miners loaded ore into narrow wagons at the face, pushed these to junctions, hand-shoveled ore into wide wagons, and sent those to the shaft. Every ton was handled twice. Labor doubled. The deeper problem was coordination between mines. Cornwall's operations clustered in mineral-rich districts. The great Consolidated Copper Mining Company encompassed 60 separate shafts across 4 square miles. Moving ore from outlying shafts to central processing required surface tramways. Each mine built its own. Each chose its own gauge. The result was a patchwork of incompatible railways crisscrossing the countryside. Britain's surface railways faced similar chaos, but resolved it through standardization. George Stephenson's 4 feet 8.5 inches became dominant. Isambard Kingdom Brunel's Great Western Railway used 7-foot gauge, superior but incompatible. By the 1840s, goods traveling Bristol to Newcastle required transshipment 3 times. Parliament intervened. The Railway Regulation Act of 1846 mandated standard gauge for new railways. By 1892, British railways operated on uniform track, but Parliament had no authority over private mines. Mining companies were autonomous industrial enterprises. Underground tramways were private equipment on private property. The state had no more right to dictate gauge than to mandate pump diameter. This regulatory vacuum meant mines made decisions based purely on local considerations. And local considerations varied enormously. The Levant mine, working a lode dipping under the Atlantic, used narrow 18-inch gauge for steep inclines and tight curves. Bottlenecks mine, working nearly vertical loads in sea cliffs, used minimal underground tramway. Great Work mines near Gwenapp used 30-inch gauge for wide loads and large ore bodies. Consolidated mines used multiple gauges because they were actually 60 separate operations under unified management retaining original infrastructure. The situation became complex when mines interconnected underground. As operations went deeper, ventilation required crosscuts to adjacent workings. These passages also allowed ore transfer. If Consolidated could ship ore through an adjacent mine to central processing, they saved surface hauling costs. But this only worked if gauges matched. In 1863, United Mines and Great Consolidated spent £180 installing compatible trackwork at the 200-fathom level. 6 months later, Great Consolidated closed that section due to ore exhaustion. The investment was lost. This was game theory before game theory had a name. Everyone would benefit from standardization, but no individual actor could justify the cost. Each mine made locally rational decisions, creating globally irrational results, the pattern repeated across 19th century Britain. Textile mills used incompatible thread gauges. Shipyards built vessels with different plate thicknesses. Gasworks operated at different pressures. Standardization would benefit everyone, but coordination costs were prohibitive without central authority. Cornwall faced an additional complication: geological uncertainty. A mine might invest £5,000 in gauge standardization only to discover ore exhaustion 2 years later. Cornish mining was speculative. Average operational lifespan was 15 years, though some lasted 50 or more. Infrastructure investments had to pay back quickly. Gauge standardization was a long-term play that might never reach payback. The 1866 copper price collapse illustrated this risk. Chilean and Australian copper flooded markets. Prices fell from £130 per ton to £75 between 1866 and 1870. Cornish mines couldn't compete. Between 1866 and 1875, the workforce fell from 18,000 to 6,000. More than 100 mines closed. Any operation that had spent capital on gauge standardization in 1865 likely went bankrupt before seeing returns. Dolcoath survived by pivoting to tin. The mine had always extracted both metals, but copper was dominant. As copper prices collapsed, Dolcoath refocused on tin loads. Tin held steady around £100 per ton. The transition required different processing equipment, but underground infrastructure remained useful. And the gauge chaos remained unchanged. The same incompatible wagons from 1866 were still problematic in 1876. The most radical solution came from new mines built after the problem was understood. Eastpool and Agar Mine, opened in 1870, standardized on 24-inch gauge throughout. Mine Captain Thomas Davy specified this in the original plan. He chose 24 inches as compromise between maneuverability and capacity. New tribute gangs were informed that any tramway had to match the standard. Davy had authority to enforce this because Eastpool lacked legacy infrastructure. The results were striking. Eastpool moved ore with one-third the labor Dolcoath required. Transfer junctions needed no manual handling. When the mine installed its first locomotive in 1876, it could access 90% of haulage levels. In 1878, Eastpool produced 2,100 tons of black tin at £18 per ton. Dolcoath produced 2,800 tons at £23 per ton. Much of that £5 difference was transport efficiency. But Eastpool's success didn't trigger widespread adoption. Existing mines couldn't justify conversion cost. New mines were rare because Cornwall's industry was contracting. The gauge diversity became locked in, a path-dependent outcome where early decisions created infrastructure increasingly expensive to change. By 1880, battery-electric locomotives transformed underground logistics. A single 6-ton locomotive costing £650 could pull 15 loaded wagons through levels requiring 40 men with hand wagons. But efficiency only materialized with compatible trackwork. Mines with unified gauge deployed locomotives across entire operations. Fragmented mines ran multiple locomotives or continued manual labor in incompatible sections. William Trevorrow retired from Dolcoath in 1873 after 43 years underground. He had seen evolution from windlass hoisting to steam winding, hand drilling to pneumatic drills, candles to oil lamps. But he watched the same gauge problem frustrate operations his entire career. His son James became shift captain at Eastpool in 1874, working where gauge uniformity was standard. The contrast illustrated efficiency lost to path dependence. The gauge chaos persisted into the 20th century. When South Crofty, Cornwall's last working tin mine, closed in 1998, it still operated multiple gauge systems installed decades earlier. The final underground locomotives ran on 2-foot gauge. Branch lines used 18-inch. Some sections retained hand-push tramways on gauge chosen by tribute gangs 130 years prior. The mine's closure ended 4,000 years of Cornish metal mining. It also ended Britain's last example of the private railway gauge wars that had consumed so much effort, capital, and ingenuity. The story reveals how local optimization can create system-wide inefficiency. Each decision made sense individually. Tribute gangs chose gauges that worked for their immediate needs. Mine captains accepted multiple gauges because conversion was expensive. Companies absorbed inefficiency rather than coordinate with competitors. But the cumulative result was an industry operating far below its potential efficiency. Modern logistics faces similar challenges. Shipping containers standardized at 20 and 40 feet after decades of incompatible sizes. Aircraft use compatible refueling systems after years of proprietary designs. Computer networks settled on TCP/IP after protocol wars. USB connectors are finally standardizing after multiple competing formats. The pattern repeats. Fragmentation emerges from local optimization, persists due to switching costs, and resolves only when coordination benefits exceed transition expenses or when authority mandates change. Cornwall's mines never reached that threshold. The industry declined before coordination became economically compelling. The gauge chaos wasn't resolved. It was simply abandoned when the mines closed. The tramways were pulled up for scrap. The wagons were sold for salvage. And the problem that had consumed William Trevorrow's entire career disappeared, not because someone solved it, but because the industry that created it ceased to exist. If this story moved you the way it moved us, do me a favor, hit that like button. Every single like tells YouTube to show this story to more people. Hit subscribe and turn on notifications. We're rescuing forgotten stories from dusty archives every single day. Stories about industrial coordination failures that shaped how we live today. Real decisions, real consequences. Drop a comment right now and tell us where you're watching from. Are you watching from the United States, United Kingdom, Canada, Australia? Our community stretches across the entire world. You're not just a viewer, you're part of keeping these memories alive. Tell us your location. Tell us if you have mining history in your family. Just let us know. You're here. Thank you for watching, and thank you for making sure William Trevorrow and the chaos of Cornwall's private railway gauges don't disappear into silence. These stories deserve to be remembered, and you're helping make that happen.